Alright, hello everyone. Welcome to our lesson today on solving quadratic equations by completing the square. Alright, let's get started. Alright, so the plan for the lesson today is we will quickly review what completing the square is and figure how we can use this method to solve for quadratic equations. Alright, so let's begin. Starting with the first question here, we just have x minus 1 squared minus 49 equals to 0. So in this case, we always want to isolate the x. Right? So to do that, we can add 49 to each side. Right? So add 49 here, add 49 here. Right? This will get us x minus 1 squared equals to 49. And now the next step, as we move through the bedmass operations, we can now square root both sides to get rid of the exponent. Right? So we'll square root both sides. So we'll square root this, we square root that. Right? So the square root of x minus 1 squared is just x minus 1. Oh, we don't need the bracket anymore because we got rid of the exponent, so x minus 1. And now the square root of 49. Our first instinct is to say 7, but you got to be really careful here. The square root of 49 is plus or minus 7. Right? Negative 7 squared and positive 7 squared both fetches you 49. Right? So from here, we can just add 1 to both sides. Add 1 here, add 1 here. So which means x will equal to 1 plus or minus 7. Right, so this is a pretty weird solution, right? What is plus minus 7 doing the solution? Technically, we could just leave the answer like this, but just to make our answer more clear, we can show off the two solutions. Right? Solution 1, we have 1 plus 7, right, which is 8. And scenario 2, where x equals to 1 minus 7, which fetches us negative 6. Right? So altogether, x equals to negative 6 and 8. So now this is the general strategy to figure this problem out. Right? So in order to even use complete the square in the first place, we have to somehow get to this form right here, where we can then move this guy over there. We square root both sides to get the plus or minus on one side, and then we can isolate the x and go from there. So this is the general motivation, or the final goal of completing the square. Alright, so here's the second problem, x squared plus 12x plus 9. We will first review how completing the square works. Right, so to start off, we can subtract away 9 on both sides, right, to give us a cleaner room to work with here, where we isolate the terms with x on one side. So in this case, the x squared and the plus 12x. And the next step is kind of like a mental note here. We divide the 12, right? We divide the 12 by 2, which gets us 6. And then we square this number, right? So we square the 6 to get 36. Right? So now with the 36, we add it to both sides. Right? Equals to negative 9 plus 36. Right? So this is how I personally do complete the square. We look at the middle number, right? We look at the middle number right here. We divide this middle number, right? So in this case, we divide the 12 to get the 6, and then we square that same number to get 36. And this is the number we add to both sides of the equation. Right? After that, we can factor it. So this just equals to x plus 6 squared. And then we do the summation over there, negative 9 plus 36. That is 25. Alright, so if you notice here, all we are doing here now is this result, right? So this number right here is what we divided the 12 by with 2. Right? So if you just grab another color here, you can see all the numbers coming together. This number goes down here, and this 36 goes to here and here. Right? And after that, we square root both sides like what we did earlier. So x plus 6 equals to, once again, plus minus 5. Oops. Plus minus 5, not just 5. And then from there, x is either 6 plus 5 or 6 minus 5, which is 11 or 1. And from there, x just equals to 1 or 11. Right, giving us the two solutions here. Right, so yeah, we use the complete the square method, and the main difference here was just do completed square and using this method to solve a quadratic equation is that we are now square rooting, right? We are square rooting both sides of the equation. That will get us a plus or minus on one side, which is now easier for us to isolate for x. All right, so now let's do another question here. All right, so in this case, let's see, give a green color here. So as usual, we try to get all the x terms onto one side. Right, so we have x, or 3x squared plus 2x equals to negative 1. From here, we divide everything by 3. Right, we divide everything by 3 because we want the x squared to just be 1. Right, we only want one x squared to work with. That will make our life significantly easier. 2x equals to negative 1 over 3. Alright, so now next step, it's good. We take this middle number here, right? So this middle number here, we divide that by 2, giving us 1. And then we square this set number. 1 squared is still 1, which means that with this new number, we have x squared plus 2x. We're now adding 1 to both sides. Right, so once again, this is the number that we just squared, or this is the number that we divided the 2 by and then squared. This is the number we add to both sides. Right, and then we can factor the left-hand side to get us x plus 1. And then sum the right-hand side, which is 2 over 3. All right, from there, nice and simple, we just square root both sides. So x plus 1 equals to plus or minus square root of 2 over 3. Right, we keep the square root because square root of 2 and square root of 3 will be irrational, so it's easier to keep it as a square root. So now from here, root 2 over root 3, we can actually just rationalize it. Right, this is a very ugly fraction. Right, and in order to rationalize it, right, so we'll write this out here. In order to rationalize it, there we go. We treat this as root 2 over root 3. We multiply both the top and the bottom by the denominator that has the root. So in this case, we multiply the bottom and the top, the denominator, the numerator, by the denominator. In this case, the root 3. When we do that, we get square root of 6 on top, and then 3 at the bottom. Right? Root 3 times root 3 is just regular 3. And we do this so that we do not have a square root at the denominator. So, but we still obviously keep the plus or minus sign. We get root 6 over 3, right? So root 2 over the square root of 2 over 3 is the same thing as root 6 over 3, right? They're the same thing, it's just we write it differently. And now the last step, right? Or it could be the last step, or you could keep going for a bit, right? We move the 1 over. We have negative 1 plus or minus square root of 6 over 3, right? So this right here is a complete answer. We do not need to break it down further like we did with the previous answers, right? We did all of this because we know that we are working with rational numbers here. There's no square roots, there's no ugly decimals. But in this case, we have a square root of 6. It gets really ugly, so we just keep it like that. So it's easier for our lives. Right? So from this step, if you like, we can also make it into the same fraction. Right? So we have negative 1 plus or minus root 6 over 3. Negative 1 equals to 3 over 3. Right? Negative 1 is just 3 over 3. Here, let's find another space here. Right? So negative 1 is just 3 over 3. And then we can add the plus or minus root 6 over 3. When we combine them together, we get negative 3 plus or minus 6 over 3. Right, so this gives us the exact same answer as that. Right, but it just kind of looks nicer because it's all just in one big fraction instead of having a number here and a fraction there. Right, so again, this is not super necessary, but it's just like a good habit to get into. Okay, so with that being said, let's pause the video here, right? So take a minute to solve those completed square questions, check it out yourself, and I'll go over the answers in a bit. Alright, hopefully you paused the video and tried it yourselves. Let's go through them. So I'll go through them pretty quickly. so the video isn't too long. Right, so first question, let's see. We move the 5 to the other side, so we subtract 5 from both sides. We divide everything by -3, so it's less ugly to work with the first number. Remember, negative divided by negative at the end right here, that gets us a positive. Okay, so from here, this one's a little difficult, right? 4/3 divided by 2 is the same thing as 4/3 times 1/2, which is 2/3. Right? That gives us 2/3. 2/3 squared, 4/9. Let's hope not. Okay, I'm not intruding the space too much. We have 4/9 here, which means that the number we add to both sides is 4/9. Right, equals to 5/3 plus 4/9. All right, so now remember, we have a negative sign here, right? So be very careful when you factor this into, to complete the square form. So x minus 2/3 squared, right? So we have 2/3 because that's the number we got when we divided this, or here's a launching here. So we divided this number by 2 to get this number, and then 2/3 now goes here. Right? And then 5/3 plus 4/9, we just multiply 3 to the numerator and the denominator. We add them up, we get 19/9. All right, the numbers are looking really ugly now, which is okay. We square root both sides. That gets us plus or minus square root of 19/3. Very conveniently, the denominators match up with both ends. So we get 2 plus or minus 9/3. All right, that's the final answer. All right, hopefully you got that. If not, that's completely okay, right? Try to work back in the problem and go from there. Again, the way I do computer square is a little bit different. It might be different than how you do it. Right, so, but whatever method works. Okay, next question. Move the 5 to the right side. So now, in this case, to make sure x squared becomes 1, we multiply everything by 2. Right, that will make the x squared into 1, or 1x squared. Right, then we get that. And then from there, 12 divided by 2 is 6. 6 squared is 36. Which means that we add 36 to both sides of the equation. We factor that with x minus 6 squared. This gets us 46 on the other side. We now square root both sides, even though there is no fractions. Unfortunately, 46 has to remain in a square root because 46 is not a perfect square. It will be irrational. Right, and then from here, we could just leave the answer like this. Right, so 6 plus or minus root 46. Again, you could also answer it as 6 plus 46 or 6 minus 46. All right, but again, those all mean the same thing. Okay, so now the last question. We're working with decimals, but all the same rules apply. All right, so as usual, we want the 11 on the other side of the equation. Right, so we add 11 to both sides. We divide everything by 0.2. Right, so first term becomes x squared. Now, 0.12 divided by 0.2. That's a weird one, but it's probably easier to visualize this in fractions. So 0.12 is 12/100. This divided by 2/10. Right, this goes to 12/100 times 10/2. So those two will get reduced down. This will get reduced down. We get 6/10. Right, so we are left with 0.6. X equals to now 11 divided by 0.02, which is just 11 times 5. We get 55. Okay, very nice. So now from here, we'll do the divided 2 thing, which gets us 0.3. We square that. Watch the decimals. It's not 0.9, it's 0.09. Okay, so from there, we got x squared plus 0.6x plus 0.09. Same thing with 55, 0.09. Okay, now we factor all of this. X plus 0.3 squared equals 255. We add it up, just 55.09. We square root everything. Plus or minus 55.09. Definitely irrational. I'm not going to even try that. Which gets at negative 0.3 plus or minus 55.09. There we go. That's the answer. Right. So even though the decimals look very disgusting, the same principles still apply. Right. So yeah, once again, if you struggle with any of those questions, that's completely okay. Try to do them again by yourself and without looking at my solutions. And yeah, that's it. Keep practicing and stay hydrated.